Hi everyone, this video is an exercise 13F question 1. In this video, I'm going to do parts C and E. So this is another question about finding the area under the curve and the area that is bounded by the curve and the x-axis. So in this question, in part C, we have this equation y is equal to x plus 3 times x minus 3. So first, let's sketch this curve and see what do we get. So first, the roots or the solutions are x is equal to minus 3, or x is equal to 0, or x is equal to 3. Okay, so we have this, which is not a very good line, so let's try again. Okay, so these are the x and y axis. So minus 3 is here, 0 is here, and then 3 is here. So and also it's a positive cubic, so it's going to be roughly like this. Yeah, so it should pass here. Maybe just to change this part a little. So let's say here is minus 3. Okay, so this is the cubic. Now we said that we want to find the area under the curve, or basically the part of the area that is bounded between the curve and the x-axis. So in this case, if you pay attention, you'll see that you have this region and also this region, which is below the x-axis. And this exercise, the main purpose of this exercise is to learn how to find the area of the curves that some part of the curve is below the x-axis, and you want to find the area of that part. Okay, so let's call this maybe region 1 and this is region 2. So first, we are going to write down the integral for region 1. So for region 1, because the total area is going to be equal to the integral, the sum of the integral of region 1 and region 2. But there is something that we should be careful about region 2, because whenever a curve, basically we want to find the area of a region that is below the x-axis, when we solve the integral, the output is a negative number. But since negative area doesn't make sense, and we always write down the magnitude, so we kind of negate that negative number, so the output must be a positive number. So that's the only thing that we should be careful in this case. So the integral is basically, so first is for region 1. So let's first expand this basically bracket. So we first get x squared minus 9 times x, which gives us x cubed minus 9x. Okay, so we write down x cubed minus 9x dx. So for the next part, it's essentially the sum of the two integrals. But since the output of this integral is going to be negative because it's below the x-axis, then we rewrite this as like minus the second integral, which is the one that is below the x-axis. So you always negate the integral that is below the x-axis. So that's the point here. Just to get the magnitude. But again, essentially we are adding the two regions to find the total area. But yeah, if you don't write this negative, then the two areas are going to cancel each other out. So that's very important to. It depends on the symmetry of the curve, but in some cases they can cancel out. Okay, so the second region is between 0 and 3. So we have x cubed minus 9x dx. So now it's all about integrating and just substituting the values. So when you integrate the first integral, so let's do that. So we get 1 over 4 x cubed minus 9 over 2 x cubed x squared, sorry, between 0 and minus 3, then minus the second integral, which is obviously the answer is the same, so it's 1 over 4 x to the power of 4 minus 9 over 2 x squared between 0 and 3. Okay, so the answer to the first integral is 81 over 4, and the answer to the second integral, once we substitute these values, is minus 81 over 4. But again, because we want the magnitude, so that's the purpose of this negative here. So minus 81 over 4 is going to give us 81 over 4. And the reason that we got exactly the same values for both of these calculations is because this curve is symmetric. So that's why the magnitudes are equal. Anyway, so the answer here is equal to 81 over 2. So that's the total area. This is the total area. Okay, now part E. So part E is exactly the same in terms of the general approach. So we have y is equal to x times x minus 2 times x minus 5. Okay, so again, we'll start by finding the solutions to this equation. So x is equal to 0, x is equal to 2, x is equal to 5. So these are the solutions, and we can also expand this bracket because we are going to need that later. So we have x squared minus 7x plus 10, and then we expand this, so we get x cubed minus 7x squared plus 10x. Okay, in terms of the sketch, so for the graph, we are going to have, so these are the values. We have 0, 2, and 5. And again, it's a positive q week. So yeah, something like this. So it's not very accurate, but you get the idea. Again, so there are two regions. So let's say this is the first region that we want to find the area of, and also this is the second region. So again, we should be careful with the second region because that's below the x-axis. Okay, so for the first region, again, the total area is equal to, so the first integral is between 0 and 2 of x cubed minus 7x squared plus 10x dx. And again, we put a negative sign because second integral is going to give us a negative output. So it's between 2 and 5. The equation is the same. So x cubed minus 7x squared plus 10x dx. Okay, yeah, now it's just about integrating and finding the answer basically. So we have a 4x cubed minus 7 over 3x cubed plus 5x squared between 2, 0. Then minus, obviously the same thing, but in a different interval. So just between 5 and 2. Okay, yeah, at this point, we just substitute the limits and solve this, and we'll get 253 over 12.